In question 10 of the exercise, the problem statement says, show that A1, A2, AN, this sequence, forms an AP where AN, the nth term, is defined as follows. So there are two parts. In the first part, AN is defined as 3 plus 4n, and in the second part, AN is defined as n 9 minus 5n. So we have to show that in each case, given this definition of the nth term of the sequence of the progression, we have to show that it forms an arithmetic progression, and then we have to find the sum of the first 15 terms in each case. So let's do part 1 first. So the easiest way to solve this problem is to actually find the first few terms of the progression and then check whether it forms an AP or not. So the nth term in the first part is given by 3 plus 4n. So by substituting different values of n, we can get different terms of the progression. So for example, if I put n equal to 1, then a1 will be 3 plus 4 times 1, so this is equal to 7. If I put n equal to 2, then a2 will be 3 plus 4 into 2, that's 3 plus 8 or 11. If I put n equal to 3, then I get a3 is 3 plus 4 times 3, that's 3 plus 12 or 15, and so on. So the sequence that I'm getting is 7, 11, 15, and the next term you can check a4 will be 19, and so on. So clearly this is an arithmetic progression with the first term a equal to 7, and the common difference d equal to 4, the difference between any pair of consecutive terms. Now another way to find to demonstrate that this sequence will form an AP is to not find any specific values, but to check the difference between, let's say, the nth term and the n minus 1th term. So what I mean by that is we already have an as 3 plus 4n. So an is equal to 3 plus 4n. So instead of n, if I substitute n minus 1, so a n minus 1 or the n minus 1th term will be 3 plus 4 times n minus 1, which is equal to 3 plus 4n minus 4. So this is your nth term, 3 plus 4n. This is your n minus 1th term, 3 plus 4n minus 4. If you take the difference of these two terms, basically if you calculate an minus an minus 1, if you calculate this difference will come out to be 3 plus 4n, the nth term, minus 3 plus 4n minus 4, the n minus 1th term. And what is this equal to? So if you subtract this, you are left with only plus 4. So the difference between the nth term and the n minus 1th term is constant. It is equal to 4. And that immediately tells us that this progression is an arithmetic progression because the difference between any pair of consecutive terms is constant. So to summarize what I've done, there are two ways to show that the progression forms an AP. The first one is that you actually calculate the first few terms of the progression, like we calculated a1, a2, a3, and then you observe that the progression actually is an arithmetic progression. The second approach is that from the definition of the nth term, you calculate the n minus 1th term, and then you find its difference. And that difference should come out to be a constant, independent of n. And that can only mean that the progression is an arithmetic progression. Alright, now that we've done this, let's also find the sum of the first 15 terms. So we have to find S15. So let's use the formula Sn. The sum of n terms is n by 2 times 2a plus n minus 1 times d. So S15 will be equal to 15 by 2 times 2a. So a is 7, so 2a is 14 plus n minus 1. So n is 15, n minus 1 will be 14 into d. d is 4. So this is what we get. So we get 15 by 2 into 14 plus 14 into 4 is 56. 56 plus 14 is 70. So 15 by 2 into 17, or 15 into 35. So 15 into 35, this is equal to 525. So the sum of the first 15 terms in part 1 is 525. Now similarly, let's do part 2. In question 11 of the exercise, here's what the problem statement says. If the sum of the first n terms of an AP is 4n minus n square, what is the first term? That is S1. What is the sum of the first two terms? Then what is the second term? Similarly, find the third, the 10th and the nth terms. So basically, we are given an expression for the sum of the first n terms, and using that we have to find the first term, and then we have to find the second term and the third, the 10th and the nth term. So to understand the key idea behind solving this problem, observe this visual representation of the arithmetic progression where each box represents a term of the AP. So we have A1, we have A2 and so on. I have shown 6 terms here. Now we are given that the sum of n terms, the expression for Sn is 4n minus n square. Now if you observe this figure carefully, what do you think is the sum of just the first term? If you take only one term, what is the sum of the first term? That's only A1. So the sum of the first term, the sum of the first one term is the same as the first term itself, which means that if you substitute n equal to 1 in this expression, you will get the first term. Why? Because S1 is equal to simply A1, the first term. And then you have S2 will be equal to A1 plus A2. And then you'll have S3 equal to A1 plus A2 plus A3, and this pattern will continue. But if you take n equal to 1, you will get the sum of one term, which is actually nothing but the first term itself. So this is how we can calculate the first term. So what is the first term? So the first term A1 is actually nothing but S1, and this is equal to 4 times 1. I'm just substituting n equal to 1. So 4 times 1 minus 1 square, which is equal to 4 minus 1 or 3. So we have found A1. Now the next question says, what is the sum of the first two terms? So what is A1 plus A2? So what is that? So that will be S2. So S2 will be A1 plus A2. This is equal to 4 into 2. So instead of n, let's substitute 2 now. So 4 into 2 minus 2 square, which is equal to 8 minus 4 or 4. So the sum of the first two terms is equal to 4. And next the question says, what is the second term? So here's now a key idea behind the solution. So we have found the sum of the first two terms, that is equal to 4, and we've also found the first term, that is equal to 3, which immediately tells us that the second term is 4 minus 3 or 1. So basically what this means is that to find the second term, you can subtract from S2, you can subtract S1. So from the sum of the first two terms, you can subtract the sum of the first term, and that will give you the second term. So let's write it algebraically. So A2 is actually equal to S2 minus S1. This is equal to 4 minus 3, which is equal to 1. So the second term is equal to 1. Now it says find the third term, the 10th term and the nth term. So what will be the third term, which is this term A3 here? So to find A3, we will use a similar idea. So we will find the sum of the first three terms, and from there we will subtract the sum of the first two terms. So that will just leave A3. So A3 will be equal to S3, the sum of the first three terms, minus S2, the sum of the first two terms. So what is S3? So S3 is equal to 4 times 3 minus 3 square, and S2, we already calculated S2 as 4. So minus 4. So this is equal to 12 minus 9 minus 4. So this is equal to minus 1. So A3, the third term, is equal to minus 1. Now let's find the 10th term. So the 10th term will similarly be equal to S10, the sum of all terms up to the 10th term, minus S9, the sum of all terms up to the 9th term. So if you take this difference, you will only be left with the 10th term. So in general, the idea is to find any term, you take the sum up to that much number of terms, and then subtract the sum up to the previous term, and then you will find that term that you're trying to find. So let's find S10 and S9. So S10 will be equal to 4 times 10 minus 10 square. So that's S10, and from this which we will subtract S9, which is equal to 4 times 9 minus 9 square. So let's find the value of this. So this is equal to 40 minus 100 from the first bracket, and from the second bracket we have 36 minus 81. So this is equal to minus 60 plus 45, which is equal to minus 15. So the 10th term is equal to minus 15. And now finally let's find an expression for the nth term. So for that we will use the same idea. The nth term is equal to the sum up to n terms minus the sum up to n minus 1 terms. So this is the key idea behind the solution. So we will find the nth term as the sum up to n terms minus the sum up to n minus 1 terms. So let's find this now. So Sn is 4n minus n square, and Sn minus 1 is 4 times n minus 1 minus n minus 1 square. So this is how we will find an. So now we can find 4n minus 4n minus 1. So that will be equal to 4. And then we will have minus n square plus n minus 1 square from the second bracket. This is equal to 4 minus n square plus n square minus 2n plus 1. And this will leave us with n square will get cancelled out. We'll get 4 plus 1 or 5. So 5 minus 2n. So we have managed to find a general expression for the nth term of this progression using the expression for the sum up to n terms. And now you can verify that this expression is correct. If you put in different values of n, you should get different terms of the AP. So if you put n equal to 1, you should get A1, which is 5 minus 2 or 3. So this is correct. If you put n equal to 2, you should get A2, which is 5 minus 2 into 2 or 5 minus 4 equal to 1. If you put in n equal to 3, you should get A3, which is 5 minus 2 into 3 or 5 minus 6 or minus 1. So that's also correct. And if you put in n equal to 10, you will get 5 minus 2 into 10 or 5 minus 20 or minus 15. So the 10th term should be minus 15, which is what we calculated. So this expression for the nth term 5 minus 2n is correct. The problem statement in question 12 of this exercise says, find the sum of the first 40 positive integers divisible by 6. So we have to find the sum of the first 40 integers, positive integers, divisible by 6. So if we write out the first few such integers, we will see that these integers form an arithmetic progression. So the first positive integer divisible by 6 is 6 itself, then we have 12, then we have 18, then 24, and so on. So this is clearly an arithmetic progression where the first term is 6 and the common difference is also 6. And we have to find the sum of the first 40 terms of this progression. So we have to find S40 for this arithmetic progression. So we are going to use the formula Sn, the sum of n terms of an AP, is equal to n by 2 times 2a plus n minus 1 times d. So this is what we're going to use. So S40 will be equal to 40 by 2 because n is 40 times 2a, so 2 into 6 plus n minus 1, so n is 40, so n minus 1 is 39, so 39 into D is 6. So this is the expression that we get for S40. So let's evaluate this. So 40 by 2 is 20 times, in the bracket we will get 2 into 6, that's 12, and we will get 39 into 6. So that is equal to 234. So this is what we get. So this is equal to 20 into 12 plus 234. So 234 plus 12 is 246. So 246 into 20, this is equal to 4920. So the sum of the first 40 positive integers divisible by 6 is equal to 4920. And this is the answer of question number 12. By the way, another way to calculate this same sum is as follows. So we have this sum 6 plus 12 plus 18 up to 40 terms. This is what we had to calculate. So what we can do is take out a common factor of 6. So if we do that, we will get 6 times 1 plus 2 plus 3 and all the way up to 40. So 40 terms inside this bracket. Now we know how to calculate the sum of the first n natural numbers. So the sum of the first n natural numbers is n into n plus 1 by 2. So this means that this sum inside the bracket will be equal to 40, which is n, into 41 n plus 1 by 2. So this is what we get as the sum of the first 40 positive multiples of 6, and you can verify that this will come to the same value, 4920. So instead of finding the sum using this formula, we could solve the same problem by taking out a common factor of 6 and then using the sum formula for the sum of the first n natural numbers.
Thank you for watching our channel. This video உங்களுக்கு பிடிச்சிருந்ததுனா கமெண்ட் பண்ணுங்க, லைக் பண்ணுங்க, ஷேர் பண்ணுங்க. மறக்காம இந்த சேனலை சப்ஸ்கிரைப் பண்ணிட்டு பக்கத்துல இருக்க பெல் பட்டனை ட்ரைன் தட்டுங்க. பை.